Okay, so first question is about numerical expression. I present to you a numerical expression and you need to use the rule for order of operations to simplify as much as possible and give me the final value for this expression. You are very familiar with the rule that we use the acronym GEMDAS, G for grouping. So any symbols that involve parentheses, brackets, braces, or absolute value. Then the next operator that we're going to look for is exponent, and then multiplication, division, and finally the last one that we take care of is addition, subtraction. Then multiplication, division by itself, you do left to right, and addition, subtracts by themselves, you just do from left to right. Okay, so I identify here two symbols that represent indicates a grouping. So I see brackets here and here, and I see parentheses here and here. So one is inside the other. I start with the inner grouping. Anything that I do not gonna work with it, I just repeat. So now I have, inside this grouping, I have multiplication, subtraction. Multiplication has priority over subtraction. So I'm going to multiply and then bring down everything else that I'm not using yet. The next one, I still have the grouping that did not disappear because it still has the subtraction. I'm going to subtract 48 minus 32, and then I get the number 16. And I will keep the parentheses no longer because it is a grouping, but because the number 3 is multiplying the result of the grouping. So I'm going to write 16 between parentheses. Now I have no more inner group. I'm going to solve the grouping of the bracket. Now pay attention, I have addition and I have a multiplication here. The multiplication has priority over the addition. So then I'm going to keep 6 plus and solving the 3 times 16. And I get the number 48. It's still one operation inside the grouping. 6 plus 48 is 54. Now I'm going to put 54 between parentheses to indicate that 54 has to be multiplied by 4. Now 4 times 54 is 216. So the interpretation of this expression, this numeric expression, it means the number 216. Okay? So I'm going to proceed for question number 2. Now I don't have a numeric expression. I have what we call algebraic expression because it contains two variables. The variables A and B. And I gave the value for A and B. So I'm going to do a substitution of the variable by its value on the original algebraic expression. Now I transform my algebraic expression into a numerical expression. And I know how to read, evaluate, interpret a numerical expression using the order of operation rule. So we had, I'm not going to write again, we had the grouping, exponent, and then, so let's see, there is no grouping here, but there is 2 exponents. So I'm going to solve the exponent. 4 that multiply this exponent. 1 times 1 is 1. I keep the parentheses now to indicate the multiplication. 2. Now I have negative 3 to the 3rd power. I'm going to see. What is negative 3 to the 3rd power? Negative 3 multiplied by itself 3 times. So let's look the signs first. This is negative and this is another negative. Multiplication of two negatives becomes a positive. Now I have a positive multiplied by a negative number, and the result is negative. So then the answer here will be a negative number. Now I multiply 3 times 3, 9, 9 times 3, 27. So the result is the number negative 27. And I put between parentheses because it's being multiplied by the 2. Now you have multiplication, addition, multiplication. Multiplication has priority. So I'm going to solve this multiplication, and I'm going to solve this multiplication. That's the number negative 54. Now I'm going to add those two numbers. Adding numbers with different signs. In reality, I do a subtraction and keep the sign of the bigger number. So the final answer here is negative 50. Question number 3. No more numerical expression, no more algebraic expression. Now I don't have expression, I have an equation. I know that I have an equation because there is an equal sign here comparing two algebraic expressions. And the question here is to solve. So I have to find what should be the value for this variable here to make the expression on the left side to be equal to the right side. Okay, first I need to simplify as much as I can. On the left side there is nothing to simplify, but on the right side I see that I could use the distributive property here. So left side stay as it is. Then I have the equal sign, and my right side becomes 6x minus 12 plus 7. The right side I can combine like terms. Then I'm going to keep the left side as it is. The equal sign, the right side, 6x, there is nothing to combine with it. Negative 12 plus 7, different signs. I'm going to subtract the numbers and keep the sign of the bigger number. Now I have to isolate, to make x by itself, and I have x on both sides. I'm going to bring x, this x to the right, to the left, and take the number from the right to the, from the left to the right. Okay, let's see. This 6x here is positive. If I add a negative 6x on both sides, I no longer have this term. This term becomes 0 because a term and its opposite when add together makes 0. Here I have x minus 10 and then equal negative 5. Now I want to get rid of the term negative 10 to make x by itself. If it's a negative 10, I'm going to add a positive 10 on both sides. These two cancel each other. Now the left side has only x and the right side has the number 5. Remember that you can always check your answer for the value that you found on the original one. So 7 times 5 minus 10. What is this? 35 minus 10, 25. This is my left expression, right? The expression 7x minus 10. I replace here. So the expression on the right is 6x, 6 that multiply x minus 2 plus 7. If I replace the 5, I have 6 multiplied by 3, so this is a grouping. I solve the grouping first. Now I have the multiplication addition, so it's 18 plus 7, and this is also 25. So this became true statement. The left side and right side are equal for the value of x equal 5. So you found the correct answer. Number 4. Okay, so you guys always have problems with manipulating fraction. And we don't want to deal with fractions because you have to find common denominators and find equivalent fractions. So there is a mathematical manipulation that allows you to find the equivalent equation from the original one by following this method. So first, I have to find the LCD of all the denominators of the fractions involved on this equation. The denominators are 3 and 5. The LCD will be 15. Then the second step is to multiply all terms in the equation by the LCD. So let's do that. Okay, so the LCD is 15. I have 1, 2 on the left side and I have another one on the right side. So I'm going to multiply everything by 15. So 15 multiplied by 1/3 of x plus 15 that multiply 1/5 equal 15 that multiply 2. I'm going to solve here on this side. What is 15 times 1/3 of x? When I have a whole number, the denominator is always 1. If it is multiply denominators and denominators. 15 divided by 3, 5. So here's 5x. So the result here is 5x. Plus, what is 15 times 1/5? Again, whole number, denominator is 1. I multiply numerators and I multiply the denominators. Try to reduce and this became a 3. So this is 3. And 15 times 2 is a 30. Now I have an equation that's much simpler, easy to manipulate, and I know how to solve an equation by making x by itself. X here has a coefficient of 5 and has a term in front of it. I'm going to get rid of this term first, getting its opposite and adding. When I add the term by its opposite, I get 0. So left side is 5x, right side is 27. Now, I don't want this coefficient of 5. I want to have just one x. So I know that if I divide a number by itself, it turns into 1. Now my coefficient is for x is 1, and I have to do the same thing on the right side. And now my answer is 27 over 5. I could do a quick check here. So let me, sorry, so to twist it. Check for x equal 27. So 1/3 times 27/5 plus 1/5. I want to see if this is really true. When I multiply this times that and this times that, I would find a no fraction. But before I multiply, I'm going to try to simplify. I know 27. This is 9 and this is 1. Then I have 9 over 5 plus 1/5. Same denominator. I keep the denominator, add the numerator, and this is 2. 10 divided by 5, 2. Yay, great. Found the answer. the correct answer. Next, okay, another equation, but this equation is called literal equation because just has letters. I don't want you to find a number for this because you have 3 variables there. But I want you to solve for a particular variable. In this case, I want you to solve for the variable L here. So it means on this that I have to look for this variable and find a way to make this variable by itself. Because this is how you solve an equation. Alright, so this variable is being multiplied by the coefficient 2 and has a term in front of it. So first I want to get rid of this term. If the term is positive, I add its opposite and I do on both sides. Now I have P negative 2W on the left side. On the right side, this became 0. And now I have 2 L's. I don't want 2 L's, I just want 1 L. So I will divide here by 2. I can divide the whole thing by 2 or put a 2 under each one of them. Either way. So I'm gonna put under the whole thing 2. And then 2 divided by 2 is 1. So now my L finally is by itself. And to find L, I have to get the perimeter, subtract 2 times the width, and then divide by 2. Okay, so you can give me the answer like that. Or from here, when you divide by 2, if you decided to do P over 2 minus 2W over 2. So I'm starting over, but then instead to come this way, I'm coming from here to here, from here to here, or here to here, okay? And then, so I know that 2 divided by 2 is 1, and here also is 1. I would have that the length also can be written as P over 2 minus W. So both answers are correct because those are equivalent equations. Did you guys get that? Everything okay? Okay, number 6. Wow, now I don't have equation, but I have an inequality. We all know that to solve equation inequality, we use exactly the same process. There is just a little twist on the inequality that I'm going to discuss later. But let's try to do this. I have 2 expressions, and I'm saying that the first expression is less or equal to the second expression. And I have to solve for x, solve this inequality. So I'm going to bring 5x to the left, negative 5x. I'm going to get rid of this 5x here, and here I'll have 12x. Different signs, I subtract and keep the sign of the bigger number. Now I don't want the negative 7 here because I just want to have an x. So I'm going to add a positive 7. If I do on one side, I have to do on the other. So now this goes to 0. Now I have 12x. And here I have the number 15. Then I don't want 12x, I want 1x. So to make this 1, I divide by 12. If I divide 12 in one side, I have to do 12 on the other side. So now my coefficient for x became 1. So x. Now pay attention to this. Is this reduced? They are asking a reduced fraction. So this is not my final answer. I see that those 2 numbers have a common factor, that is the number 3. So here is 5, and here is the number 4. Oops, instead see I have to keep the sign, and I changed to equal here. I made a erroneous mistake here. So I have to keep this sign. It's not equation, it's the inequality less than. So then this is my final answer. If you want to check your answer, you can do that for a particular value for x. For example, 5/4 represent as a mixed number 1 and 1/4. And the solutions is all numbers that is less than this 1. Okay, what is a number that is smaller than 1 and 1/4? It's the number 1. So I'm going to test for x equal 1 to see if the left side is really smaller than the right side. 17 times 1 minus 7. This is what number? 10. And then the right side is 8 plus 5 times 1. And this is 13. Is it true that 10 is less or equal to 13? Yeah, this is true. So it means that I found right values for x. That makes the inequality a true inequality. Yes. Okay, all right. All right, so I found the answer. So far, so good, right? And then, so I make a line because my answer is for all numbers that are less or equal 5/4. I know that 5/4 is 1 and 1/4 because I know how to change into a proper fraction to mixed number. And I want to get a sample of a number that is less than that and check here if this will make the statement true. So the closest one, the easiest one that I found is the number 1 because 1 is less than 5/4. So I'm gonna check one example for x equal 1. You could choose 0, you could choose negative 200, you could choose any number that is less than 1 and 1/4. I chose 1. So the 0 would be a good one too to try because it's less calculation. And then I replace, so here is my left side expression. The left side of my expression, I replace x by the number 1 and got 10. The right side of my expression, of my whole inequality, 8 5x, is the right side of, is the expression that exists on the right side of the inequality. I replace x with 1, and I get the number 13. And this whole inequality says that the first value, the value that's on the left must be smaller than the one that's on the right. And using the x equal 1, I see that this is a true statement. So then I feel satisfied that my answer has a good chance to be correct. I'm not proving it, I'm just getting one example to show that the possibility is very close to be true. Okay, so now this one. The purpose of this this question here is to see if you can identify the equivalency between an interval notation and a particular graph. You have to know very well which one is equivalent to which one. So let's look at this on the graph. This graph is pointing to the left, is going forever. So here goes to negative infinity. And here, do you see that the 6 has a close circle here? Is including the 6. When including the 6, I use brackets. And my bracket is to this side because all my numbers is going to the left. And of course, the infinity, I never get there, so it is a parenthesis. Which one looks like that? Is this one. See, negative infinity to 6, including the 6. So this is C. Now let's look at this one. This one is going forever to negative infinity. Then I know that here must have a parenthesis. This point here, negative 2, is open, is hollow. It means that I'm not including the negative 2. Any number extremely close, but not the negative 2. So there is another parenthesis right here. Which one matches this? The D. Now the right side. The arrow is going to the right forever because there is an arrow. So it's going to infinity and beyond. Then, so I know that I use here parentheses. A hollow point here, not including the 6. Another parenthesis here. So 2 parentheses starting 6 and going to infinity. So this is the A. And finally the last one. Okay, it's going forever to the right. It's going to infinity. So here I know that's a parenthesis. I never reach the infinity. And here is a closed dot. So it means that I do want the negative 6. So I use the bracket to embrace the negative 6. So negative 6 to infinity, and then here is the B. Okay. Next one. Number 8. Oh, okay, so this is a good one. We have, like I ask you guys always, to read a word problem and try to model before you start getting numbers and manipulate them. Okay, so we are talking about a rectangular room. So I'm gonna draw a rectangular room as much as I can. And this rectangular room is 3 times as long. So 3 times means multiplication, 3 times, as long as it is wide. And its perimeter is 32 meters. So let's write here, perimeter, P uppercase, that we normally use, is 32 meters. The length of this room is 3 times its width. I do not know what the width is. Nobody told me what number it is. So I'm going to choose any variable. I'm going to call this width x. And then my length has to be 3 times this x. So I'm going to put x here. And I'm going to put 3x here. And of course, if in a rectangle, by the definition of a rectangle, if one length is 3x, the other side must be 3x. If the width is x, the other side is also x. Now, definition of perimeter. You know that the perimeter is when we add all the sides of a shape. In this case, it's a rectangle. I can add everything around and say that this is 32. Or I can use the formula. So, the formula for perimeter is 2W's plus 2L's. If you're the one that likes formula, you use this one. If you don't care much about formula and you understand that perimeter is to add everything that's around, I'm gonna start to add. So I'm gonna put x plus 3x plus x plus 3x equal 32. Or I'm gonna say 32 equal 2 times, the width is x, plus 2 times the length is 3x. One or the other. Here is a bunch of like terms. I can combine them. Here has 1, 3, another 1, and a 3. So when I add them together, I have 8x, 32. Then how do I find x? I divide both sides by 8, and I find that x is 4. Okay? Now let's finish to the right side if you are the one that's using formula. 32 equal 2x plus, what is 2 times 3? 6x. 2x plus 6x, 8x. 32. Now I'm going to divide the same way here by 8, and I have 4 equal x. Now let's go back. Don't jump and put your answer that your answer is 4. Let's see what the problem is asking. They are asking the length of the room. Your x is the width. So here is 4. And here also 4. So if the length is 3 times, it will be 12. And here it will be 12. Then your final answer is width is 4 meters, but the length is 12 meters. And this is what this problem is looking for. This problem here is about simple interest. And I know a formula to deal with simple interest. I use I equal PRT. So anytime that you see a problem where there is borrowing or investing in with a simple interest rate, you're gonna use this formula here. IPRT, I print. That normally we said this in class. And I have to identify the values of the variables and which variable that I want. So let's read this. Kylie financed a car for $9,000 at a simple interest rate of 6%. She financed the car for 4 years. How much interest did Kylie pay at the end of 4 years? And pay attention, they want you to round to the nearest cent because we are talking about money, right? Okay, so they want, what do you know? You know the principal, the main value. The main value that's being financed is the $9,000. The interest rate is 6%. The 6%, remember, this is the English way for us to talk about a decimal value. That is the decimal 0.06. We never use 6. We use the corresponding mathematical interpretation of 6%. The time, how long he gonna borrow this money? For 4 years. So then I come here, and what I want is how much interest Kylie you're gonna pay after these 4 years borrowing this money to buy the car. So if you identify all the 4 variables and put interrogation the one that you want, you just come use the formula, replacing what you have and leaving the variable that you want to find. So PRT, they are multiplying each other. So 9,000, the rate 0.06, how long? 4 years. Okay, so I do not know if you guys remember the trick. I have decimal point here with 2 places, and I have 2 zeros here. Each time I go to the right, I cut 1 0. I go to the right and I cut another 0. So now I have 90 times 6 times 4. So 90 times 6, and then I have 540. And then I multiply 540 times 4. 0, 16, 21. $2,160. So it means that Kylie gonna borrow $9,000 to buy her car that she gonna pay slowly in 4 years, and at the end she gonna pay back this whatever this place that financed for her $2,160 extra. Be very diligent identifying the variables before you use the equation. Okay, this one is an easy thing that we see all the time, everywhere, every time that we decide to buy something. An antique has a price tag of $219. The sale tax rate for the county is 8%. How much sale tax will be due? So this person will pay the $219 plus the 8% over on the value of that antique. So how do you represent 8% mathematically? It's the decimal 0.08. So if I want to know what is 8% of this value. 8% is 0.08. Of means multiplication. So I have always to multiply the 8% or the 0.08 decimal number by the value of the product that I'm buying. So here I'm gonna do the multiplication. $72, 8 and 7, 15, 16 plus 1, 17. I have 2 decimal places here. So I start with here and I walk 1, 2. So this is the price of the sale tax that I'm gonna pay on this antique is $17.52. Additional of the value of the antique itself. Okay, now we are on chapter 3. The chapter 3 is about linear equation. And they want you to find the y-intercept of the linear equation. So I know that is a linear equation because it has 2 variables, both are degree 1, and is an equation because it has the equal sign. You know that the y-intercept is an order pair where your x, the x of the order pair is 0. Okay, so then I come on the original equation, and when I see x, I replace by 0. Then 2 times 0 is 0. So this term disappears. Now I have 3y equal negative 18. Then I divide 3 on both sides. And I get y equal negative 6. So when my x is 0, the y must be negative 6 on this linear equation. And you have to know the rules. The x-intercept is the opposite. What is 0 is the y. And then wherever you see the y, that term becomes 0. And then you solve for x to identify the other number for the order pair. Slope of the line that passes through the points. So I'll give you 2 points and they are asking for the slope of a line. The slope is the equation that we use for the slope when I give you 2 points of the line is y2 minus y1, x2 minus x1. Pay attention, makes totally difference. Y's are the y's, they are on the numerator on top, and the x's on the bottom. Is rise over run. Rise is vertical, and run is horizontal. So if I call this my point 1, and this my point 2, it means that this is x2, and this is the y2. This is x1, and this is the y1. Okay, so is paying attention with signs, I'm going to replace. My y2 is what? Negative 8. Minus, what is y1? Negative 11. What is your x2? 9. And what is your x1? 5. Be very organized, need to identify the signs. Okay, I have a negative here that is multiplying by another negative. So those two multiplying by each other makes a plus. And here there is a 1, but I don't need to write 1. So this turns into negative 8 plus 11. And my denominator becomes number 4. What is negative 8 plus 11? I subtract the numbers and keep the sign of the bigger number. So the slope of the line that passed through those 2 points is the slope 3/4. Okay. Now I don't have 2 points, but I have an equation that define a line. And they want you to find the slope looking to the line. The only way that I can immediately find out the slope if I have the equation in this form here, in the slope-intercept form. Okay? And this is not the slope-intercept form because the slope-intercept form requires the y by itself and a coefficient multiplying the x plus a constant. So this is another format. So this is the standard form. But I know how to deal with this, converting the standard form into the slope-intercept form by making y by itself. And I'm very good at this because you have been working on that. So first is this coefficient that should not be here, that I don't want to be here, and is a negative 9x. So if I put a positive 9x, I'll make this disappears. But if I do anything in one side of my equation, I have to do the same on the other one. So this disappears. Now I have only the negative 3y. 9x plus 17. I cannot combine this at all because this is a variable term and this is a constant term. And I don't want any coefficient in front, I just want the coefficient 1 in front of it. So to be 1, I have to divide by the coefficient itself. A number divided by itself makes 1. Then I do the same here for this term and for this term. This here now becomes 1. 1 times y is just y. 9 divided by negative 3 is negative 3x. And a positive 17 divided by a negative 3 is negative 17 over 3. Okay, so now I have this format just like that. And there is a coefficient in front of the x. This coefficient here is it is the slope of the line. So your m for this case is negative 3. So those are the problems that, for example, they can give you equation in slope-intercept form. So you just come look for the coefficient of the x, and this is your slope. But when it has a standard form, you convert to slope-intercept form and identify the coefficient of your variable x. Okay, I put this here for you to have a good view of the different inclinations of the line. When the line is inclined to the right, you have a positive slope. When it's inclined to the left, is a negative slope. If it's horizontal, your slope is 0. And if it is vertical, it's undefined. So this here gives you an equation very easy. Y equal 1. Simple, not easy. It's a simple one, the simplest one. In the horizontal, you have y equal negative 1 in this case, right? He's here under the 0, negative 1. And this here is x equal negative 2 for these two cases. All right, so let's see this. What equation represents a vertical line? A vertical line always starts with an x and equal the point of intersection here. What is this point here? Negative 9. So the equation is a very simple equation. You start with the variable x because it's vertical, and you find the x-intercept here. That's negative 9. Okay? 15. Again, I put the same picture here because we're going to try to be efficient solving this. Okay, is this a slope-intercept form? Yes, perfect, super easy. Then I don't have to manipulate, get the standard into slope. So this means that this number here represents my slope. You see that the slope is negative. If the slope is negative, we are talking about this type of inclination here to the left. And this here represents the y. The y of the y-intercept. So the y-intercept here then is 0, negative 3. So just looking here, I know that the line has to be inclined this way here. and has to be on the y-intercept. So if I go down, I know that A and B does not fit because the inclination is not correct. So it has to be one of those two. Then I just identify that the y-intercept is -3. So this, the y-intercept is the +3, and this is -3. So then my answer will be the D. Okay, so once you know the slope trends, so you can easily identify those things. Okay, now we move to chapter 4. Chapter 4 was all about polynomials, about the rules of exponents, and this is what we're going to see here. Alright, so I have a polynomial with several terms, and I started there asking me to simplify this polynomial. So I have to look for equivalent terms to combine them. So I see that this term is a x4 and this one as well. One is -5, the other one is 8. So when I add them together, different signs, I subtract and keep the sign of the bigger number, x4. The next one is x3. I have a x3 here, and I have a x3 here as well. Keep the coefficients, one is positive, the other is negative. So I subtract the numbers and keep the sign of the bigger number. So the x only happened one time. And the 1 only happened, the constant, only one time. Pay attention that was asked to write the expression in descending order of degree, right? So degree 4, degree 3, degree 1, degree 0. And then that's it. 17. Oh, here we're gonna start using exponential rules. Okay, so the first rule that I know that I can use here, so let me write here. As I use the rules, I will write what I'm using. The first one that I'm going to use is that if I have two bases that are the same, and I multiply each other. So I keep the base and I add the exponents, is what I did here. So let's see if I can do this here. Here I have multiplication, everything is multiplying. This base and this base are the same. So I'm going to multiply the coefficients of the monomials, 3 times 3, 9. And I can keep the base y and I add the exponents, 4 plus 8. And then here will be 12 y 7. So it will be 9 y 12 and 12 y 7. Now I'm going to use another exponent rule. If I have an exponent and another exponent divided by each other with the same base, I keep the base and I subtract the exponent. So now, pay attention to the coefficient. Do they have a common factor? Yes. I can see that the common factor here is the number 3. So I'm going to divide numerator and denominator by 3. So this is 3 and this is 4. Now I have two powers, two exponent expressions with same base. I keep the base y and I'm going to subtract the exponent, 12 minus 7. So then this will be 3y fifth over 4. And you see that the power is on the numerator because there is more y's on the numerator than on the denominator. So then always, sometimes you guys ask, oh, where do I put the base, on the numerator or denominator? You always put where there is most, because you're subtracting, the difference goes where there is the most number, there are the most number of y's. Then I am simplified, making use of two exponent rules. Oh, another one. On this one here, let's see. The first exponent rule that I know that I can use here is I know that if I have two terms multiplying each other, and they go in a power, I distribute the power. So let's look here. I have -5 that multiply x4 that multiply y7. So this is a case like that. And all this is on the power of 3. So I'm going to distribute the power of 3 on each piece of the multiplication. Do not forget the negative, so -5 to the power of 3. x4 to the power of 3. And y7 to the power of 3. And remember, everything is multiplying each other. There is no sign to put here or anything. They are very close together. And so I use this exponential rule. Now I know another rule that says the power, if I have a power to another power, I keep the base and I multiply the power. So I come here. This one is not power of power, but I know how to, let's put here. What is -5 to the power of 3? Is multiply -5 by itself 3 times. So the sign is negative. We have seen this before. 2 negatives makes a positive, positive with a negative makes a negative. 5 times 5, 25. 25 times 5, 125. So the number here is -125. Now x to the 4th to the 3rd. So you'll be x and then I multiply those two. 12. Y and I multiply those two. 21. So on this problem, I used those exponential. 19. Okay, 19 is one more. So they really want you to pay attention. They really want to see if you guys know the exponential rules. So, exponential rules that I'm going to use here. Okay, I see that a -2, b is 0. They are multiplying each other into the power of -4. So I'm going to use the distributive rule that says if I have ab to the power of any, I have a to the power of any and b to the power of any. It's the first one I'm going to use. So I'm going to do a -2 to the power of -4. That multiply b to the power of 0 to the power of -4. Now I have power of a power, so I'm going to use the rule. The a m multiplied by n. I come back here. What is negative 2 times negative 4? Is positive 8. What is 0 times negative 4? Is 0. I didn't finish because I know another property that says any base to the power of 0 is 1. So this here is 1. Then my final answer is just a to the 8th power. And here I made the use of 3 exponential rules. Okay, so we have covered the 7 exponential rules total. So you have to go and review them. Be sure that you're covered. Subtraction of polynomials. We have a trinomial subtracting by another trinomial. So the first thing that I'm going to take care here is that when I have a negative applied to a whole polynomial, I will have to change the sign of each coefficient of the trinomial. So here I don't need the parents because there is nothing in front of it. I copy as it is. Here I'm going to start changing the signs of the coefficients. So this became positive for x4. If this becomes 8x3. And the last one becomes negative 5x. Okay, now let's just look for like terms, combine them, and I'm done. Okay, and here they are asking also in descending order. The term of highest degree here is this one here. In this one there is no order of power 4, so I'm going to just write here 4x4. Now I have 2 terms with power 3, x3. Negative 5 plus 8, different signs I subtract and keep the sign of the bigger number. Now I have this one here that is x and this one here that's also x. Positive 8 and negative 5. So I subtract them, keep the sign of the bigger number. And then I have negative 10, that's a constant, and there is nothing. Okay, let me see if I, instead, let's mark different, right? Because I put this in a circle, I'm going to put this in a square to show that they're different. Are they sure in descending order of degree? Yes, degree 4, degree 3, degree 1, degree 0. Okay, so let's write the answer as an expression in, again, descending order. Okay, so this is a exponent. The base is 5x minus 2 to the power of 2. So it means that I want my base to be multiplied by itself. How many times? 2 times. So this turns into a multiplication of 2 binomials, and you know how to use the FOIL method. You multiply the first with the first, second, then the second with the first, and the last. So 5x times 5x, 25x squared. 5x times negative 2 is negative 10x. Negative 2 times 5x is negative 10x. And negative 2, now this is the last one here, Negative 2 times negative 2 is positive 4. I can combine, and I must, because it has to be simplified. They tell to expand. Expand means I'm going to use the definition of exponent to expand into a multiplication of two of the bases. And then I simplify by combine like terms. So 25x squared. Same sign. I add and keep this sign. Plus 4. Descending order, it is degree 2, degree 1, degree 0. I see another descending order. And I say, okay, now they have a rectangle that's blue shaded, and I want the area. I know that area is always the length times width. So then the area is, the length is 5x plus 3. The width is 5x minus 3. Again, here I can use the FOIL. 5 times 5x is 25x squared. 5x times negative 3 is negative 15x. 3 times 5x is plus 15x. And 3 times negative 3 is negative 9. The only ones that I like terms is those two, and they are opposite from each other. They are opposite terms. One carries the negative and the other carries the positive, so they cancel each other and make a 0. So then I am left with the first term, that's degree 2, and the last term, that's degree 0. So this is the area of this blue shaded rectangle. Now we are on chapter 5. Okay, so this is a polynomial that has 4 terms. I am not asking you to simplify. I'm not asking you to put them together. I'm asking you to factor them, to replace them with a product of 2 simpler polynomials. And I'm going to use the grouping here because the number of terms is even, and I cannot find the greatest common factor across all the terms, but I can do by grouping 2 by 2. Here I see that what is common is y. Then I factor out, I found the first factor. And the second one will be what is left after I factor out the y. I'm left with x on the first term, and I'm left with positive 7 as the second term. Okay, so this piece here transforms in a product of y and x plus 7. Now let's see this. What is common here? The negative sign is common, and the number 3 is common. Now, what is left when I factor out the negative 3? I'm left with positive x, because the negative is here, and I'm left with positive 7, because the negative is here. I take a look again, my polynomial with 4 terms turn into a binomial of 2 terms. This term has x plus 7, and this one also has x plus 7. It means that I can factor out what is common. I'm going to factor out x plus 7. And then I will rewrite the other factor as the new binomial without the x plus 7 that was factored out. So this term here becomes only y, and here becomes only negative 3. So then this is the answer. I transform my polynomial into a product of 2 binomials. And this is the method of grouping. Write the answer as an expression, factoring completely. This is a trinomial. The lead coefficient is 8. We have two different methods that we use. When the lead coefficient, when I say lead coefficient, is the coefficient of the term of highest degree. When here is 1 or different of 1. I'm gonna present here two different ways to solve the slide divide or the grouping. Okay, slide divide tells me to do this. So I have a trinomial where the lead coefficient is 8. I slide the 8 right here and multiply. Then I rewrite this as x squared plus 6x minus 72. Then I reduce this in a lead coefficient 1. And then I use the x gain to find two numbers that the product is negative 72 and the sum is 6. So the 72 indicates product and 6 indicates the sum. So those two numbers will be 12, number 12 times 6. 12 times 6 makes 72. But I have to decide which one is negative because the product is negative. But the sum is positive. So if the sum is positive, the bigger number has to be positive. Then this is the negative number. So then I immediately know how to write this into a product of two binomials, just using the numbers that I just find out doing the x gain. I don't stop here because I slide the coefficient. Now I have to divide by the number that I slide. I slide 8, I have to divide the constant part by 8. Then I see if I reduce this or not. Yes, so this has a common factor that is the 4. So I will write this as x plus 3 over 2. Can I reduce this one? I look, yes, they have a common factor that is 2. And then I write x 3 over 4. Now I slide back the 2 in front of the variable to be its coefficient. So then my answer is 2x plus 3 and 4x minus 3. Okay, so if you have used this method, it's called the slide divide method. Slide factor divide. Now the grouping method. You start with the original one, 8x squared plus 6x minus 9. But you have to know when here is not 1, your x gain has to be done multiplying 8 minus 9, that is negative 72, and addition is the middle number, 6. Then see that you have the same kind of game that you played before. So you have 12 and the 6. And this has to be the negative. But here, instead to go ahead, what you do, you're gonna replace the middle term by the sum of those two. So you're gonna rewrite your trinomial and transform into a polynomial with 4 terms. 12x minus 6x minus 9. So see that you use this 12 here and use the negative 6 here. Now a polynomial with 4 terms, you can do grouping. What is the common thing that you have here? Is the 4 and the x. Then you have 2x plus 3. Here what is common is negative 3 is common. Then here, when I factor out the negative 3, this becomes 2. Because remember, there is multiplication. Negative 6 divided by negative 3 is 2x. And then negative 9 divided by negative 3 is plus 3. Now, the polynomial turns into a binomial with a common term 2x plus 3 that I can factor out. And then the second binomial will be what is left. Is left 4x on the first one and is left negative 3 on the second one. Alright, binomial. This is a binomial and it's a special binomial. It's a difference of perfect square. So the first term, I know that is a perfect square of what? Of 3 and y. And how is the 25? 25 is 5 squared. So I rewrote this represent what is the base and the power of 2. So it's a difference of 2 perfect squares. So then how is the factorization of a difference of perfect square? Is 3y minus 5, 3y plus 5. So you have to take the square root of this, the square root of this. And one carries the positive sign, the negative sign, the other carries the positive sign. 26. Now you're going to solve an equation by factoring. So this is a trinomial, and this trinomial has to be 0. What is the values for x that makes this 0? You have to factor the trinomial, leave the coefficient 1. And then the only method that you need to do is the x gain. The x gain, you put a big X. On top is the multiplication, that is 55. And the sum must be 16. So this is 11 times 5. Because 11 times 5 is 55, 11 plus 5 is 16. So I think this is where you guys might spend more time trying to figure it out. Product that make 55 is just 1 times 55. I cannot use 2, I cannot use 3, I cannot use 4, and then finally I have the 5. So then this is the two candidates that make be true, 5 and 11. Then I check if the sum is 16. Okay, if it is, I can rewrite this as a product of two binomials. I use the variable, pay attention, the verb is x, and then I put x here, and then I put one number 11, and the other one with the number 5. And this has to be 0. And then here I use another property of multiplication by 0. That means a number must, when two numbers are multiplying by each other, they must, one of them must be 0 for the result to be 0. Then I can break this down because this is a multiplication. I can say that x plus 11 must be 0 or x plus 5 must be 0 for this product to be 0, for the whole product to be 0. Then I know to solve this simple equation. I subtract 11 on both sides, x negative 11. And here I subtract 5 on both sides, negative 5, because I wanted this to be 0. Now I have x equal negative 5. So those are my two answers. Don't write the answer as a list of reduced fractional integers, separate by comma. Then I would write negative 11, comma, negative 5, or they don't say to put in order or anything. I could do both ways. Okay. 27. Okay, see, this is a problem that is back on chapter, I think, chapter 3. It's about proportion. I have two triangles that they are said to be similar. Find the measurement of the missing side of the triangle picture below, where the measurement is given meters, and write your answer as an integer or decimal. So when two triangles are similar, their correspondent sides are proportional to each other. So this side here that has the 12 correspond to this one, the same way that this correspond to that one. And we write as, so proportion we write as a fraction, right? So 12 is to x the same way as 6 is to 18. So on top, I put the triangle 1. So I'm going to call this the triangle 1. And this is the triangle 2. And here I'm putting information of the triangle 2. So the 12 from triangle 1 is correspond to the measurement of the x of triangle 2. The same way that the 6 correspond to 18. Then I cross multiply, find the equation, and solve for x. Divide by 6 on both sides. This is 1, then this becomes x. I can simplify those two numbers here. 12 divided by 6 is 2. 2 times 8, 36. 36 meters. Let's see if your number makes sense. Our number makes sense. Okay, this triangle was 6 and became 18. What happened with the triangle? This side was expanded by 3 times. So it means that for them to continue to be similar, this side also has to be tripled. 12 times 3 is what? 36. So you can take a look and observe this and don't need to use the whole method. But sometimes the numbers are awkward and you cannot immediately perceive this how they were expanded. And then you have to use the proportion in terms of fraction and cross multiply. Is this clear? Okay, 28. Okay, so this is another problem about proportion as well. So there is a basketball season. The Panthers won 30 games out of 110. If I keep this rate or this proportion the same rate, how many games will they win in a normal 120 game season? So let's see. The number of winning games, and this is win and total. I can write a ratio. So 30 win out of 110. How many they wins? They want to know how many games they win. So how many games they win if they play 120 games and they want to keep the same rate. So this is when you see this term here, we're talking about to keep the same rate, and I gave you 3 numbers and I want to find the 4th one. We are talking about proportion. Now I can use cross multiply. I have 110x equal 30 times 120. Then I divide 110 on both sides. Here my coefficient became 1. Now I have x equal. I simplify the zeros. 360 divided by 11. I immediately see that this will not be a whole number. It will be some kind of a decimal. But then the problem says round to the nearest whole number. So I have to find what is my decimal number what is the number on the 10th place to see if I have to go up or stay as it is. So now I'm gonna go for the division of the number. $360. So I cannot put 11 to 3, but I can put in 36 3 times. And then I have 33 here. And then finishes with a 3. Now I put it down the 0. It goes 2 times into 30. 11 goes 2 times into 30. 22. Left over 8. No more to put it down. For me to add a 0, my leftover, I have to put a decimal point here. Then I put a 0 here. And 11 goes into 80 7 times. I don't need to continue because I want to round to the whole number. So if I use a 7 here, so for me to round to the whole number, I need to add 1 here and get rid of the decimal. So they must win, if they keep the same rate, they must win about 33 games out of the 120 that they play. One problem from chapter 6. Chapter 6 will be 1-2 problems maximum. It's about the radical, and they simplify to the max with a square root. Okay, so you have here outside 5x to the 3rd power multiplied by square root of a monomial that is inside of the radical. That's called a radicand. So how do I write 81 as a power of 2? So is this a perfect square? 81 is a perfect square of 9. So this is 9 squared. Because the index is 2, because it's a square root, I have to transform this into an even number. So this is x6 times x. And this is y4. Now I'm going to try to put things outside. If I have a 2 as a power and I have a 2 here, the 9 goes outside of the root. This is a 6, and I want to see how much it does go out. If this is 2 here, 6 divided by 2, so I have 3 x's that go out, half of it. This is an odd number, it's just x, there is no pair to go with it, it stays inside the root. And now here is the 4, so it means that we're gonna go 2 out. And then the only term that stays inside the root is the x, because there is nothing that, no other pair that goes with it to be able to take outside. Now all this is multiplying, and I know how to multiply those things using the power rule, the exponential rule. 5 times 9, 45. x3 times x3 is x6. I add them because they have the same base. The y2, there is no other y to go with it. And this is the 5. So the only thing that you have to see here, if you can put them in powers, even power, because we are inside a square root. So if it is an even power, you leave them out, you take them out, reducing them by 2, dividing them by 2. So 2 divided by 2 is 1, and then go out as 9. 6 divided by 2 is 3, then go out from the root as 3. 4 divided by 2 is 2, then y goes out with the power of 2. In this poor guy here, there is no other x to make a pair with it, so it's alone and stay there by itself. Then the problem is for you then combine everything else. Then you use the exponent rules to do that. And then you have the simplification. Last one, we're there. Okay, so this is the Pythagorean theorem. I try to get a picture to put here to make easy for you to understand. So we can only talk about the Pythagorean theorem when we have a special type of triangle, that is the right triangle that has a 90-degree angle here. Has one 90-degree angle. And then so the square of the hypotenuse, that's the line opposite to the angle, it's called hypotenuse. A square of it is the same as the sum of those two squares that are made by the smaller sides. See how the color tells you. So they say here, let's read the problem and I always try to make a more. I have a rectangular garden. The length of the garden is 28 feet. So it's 28. The length we adopt to be the longest side. 28. If you walk diagonally across this garden, you're gonna walk 35 feet. A diagonal, it crosses from one side, one vertex, to the opposite one. Could be that way too, so I'm gonna walk this way. Suppose that this is straight, I guess. So I walk diagonally across the garden and it measured 35 feet, this walk. And now they want to know what is the width of the garden. What is this x here? So when I look the bottom part, I see a special triangle, and it's no, there is a right triangle because a rectangular always have a right angle in each corner. So then this is my 35 is my hypotenuse, and those two 28 and x are the legs of the triangle. The legs are the sides that form the right triangle, the right angle. Then I can use the Pythagorean theorem to find this x. It tells me that the hypotenuse square, the square of the hypotenuse, is the sum of the square of both of the other side. So if you know how to put this together, now we have to solve. So I'm gonna do here 35 times 35. 25, 2, 17, 15, and 10, right? 15, 10. Okay, here is 1. So 5, 12, 2, and 1. So this is the number 1225. X squared plus. Now I'm going to do 28 times 28. 8 times 8, 64, goes 6, 16 plus 6, 22, here goes a 0, 16 goes 1, and here 5. When I add, I have 4, 8, 7. 784. And I want to find the x. Not see that x is squared. So I have to add the opposite to get rid of 784. So here, 0. Now when I work this subtraction here, I have 1. I borrow here, becomes 12, and then becomes 4. Here I borrow, becomes 11, and then here is become 4. So 441 is equal x squared. I don't want x squared, I want only the x. So I'm going to take square root from both sides. So here becomes x, because 2 divided by 2 is 1, go out as an x. Now the question is this a perfect square? Let's see, how do I determine this? I know a trick of finding the factors. 4, 4, 1. If I add those digits here, I know that this is divisible by 3. 4, 4, 8 plus 1, 9. So I can divide this by 3. When I divide this by 3, I get 1, then there is left over 1, and then I use 4, there's left over 2, then I use 7, 147. Is this divisible by 3 again? So let's see, 1 plus 4 is 5, 5 plus 7 is 12. 12 is divisible by 3, so then the whole number is divisible by 3 again. So I use 4 here, there is 2 left over, then down 7, and then there is a 9. Now 49, no longer divisible by 3, but I know that it's divisible by 7. 7, 7, and 1. How cool is that? So, now I have 3 is squared times 7 is squared. What happened? I can put 3 out of the root and 7 out of the root. Now I have 3 and 7. So x is 21. So I just find out that 441 is a perfect square of the number 21. And this is my answer. So, the end.